Now that we've introduced the idea of a function definition, I want to spend a little bit of time giving you a mechanical way of thinking about how function invocations work, and in particular how the right kinds of values get stored in the right places. So we're going to use the idea of what's often called an environment to understand how bindings of variables take place. And here's the basic idea behind an environment. It's going to be a formalism for tracking the bindings of variables and values. And it in fact apply to general bindings of assignment statements as well as more broadly to when we do function calls. So indeed, whenever we do an assignment statement, that simply pairs a name and the value of the other expression together in a table, if you want to think of it that way, that we call an environment. If we want to get the value of a name, invoking that value, or that name rather, just asking for the value of that name, simply goes to the table and looks up the value and returns it. Generally, when we're talking to a Python shell, there is an environment. It's often called the default or global environment, and it contains the bindings of all the expressions that we put in as we deal with it. And then, the key piece of this is, when we evaluate a definition, it pairs the name of the function with the details of the function without actually evaluating those details. It creates a pairing of the name to what we call a procedure object. Let me show you a graphical way of thinking about this. Here's a little bit of a description that we're using. I have evaluated two expressions. I've evaluated an expression that binds x to 5 and that binds p to 3. And over here, I have my global environment. This is the environment to which the Python shell is talking. And in fact, when I evaluate these assignment statements, they create bindings of names to values. X is bound to 5, P is bound to 3. I've also bound result down here. It's bound to 1 over in that environment. That gives me names and variable names and values as associations. And now imagine I want to run a little piece of code. There's a little for loop here. I'm not going to worry too much about the details. We'll come back to it. But basically, this for loop is going to run using an iterating variable turn over the range from 0 up to p minus 1. We know is going to be 0, 1, and 2. It's got a print statement in there, but it's also got an expression down here. And here's what will happen if I evaluate that. We know what should happen, but in terms of the environment, when I want to evaluate this expression, it says get the value of result by looking it up over here in the environment. Get the value of x by looking it up here in the environment, multiplying them together, and then rebind result to that value. That was when term was equal to 0. Having done that, we go back and we say turn equal to 1. And we do the same thing. We get the value of result. We get the value of x by looking them up in this environment here, doing the computation and rebinding result to 25. Turn goes up one more. That's equal to 2. Which is going to be the last one. And we again do the same kind of computation, getting result, x, multiplying together, and rebinding result. So my rules now are just amplified a little bit. I'm actually just keeping track in this environment of the bindings of variables, looking them up when I need them, and rechanging them with assignment statements when I have to. And so after I've executed all of this, my environment would look like this, so that if in fact I said to Python, what's the value of result, it would look it up in that environment and return the value. So this computation does what I expected it would do. But we can see how this idea of an environment gives us a little bit more formalism for thinking about what happens as we do those evaluations. Now, let's see what happens when we create a procedure object. So, again, I'm going to bind, in this case, x to 5 and y to 3, and there are my bindings right there for it. And when I give the Python shell a definition, whether I load it in from a file or I type it in, it is going to associate with the name in the environment what we call a procedure object. So it's got an identifier that says this is a procedure, and inside of it, it has the parameter list, and it has the body of the procedure. And notice the form, which is important. It doesn't have substitutions for x and y here. It has them as variable names. That means that this procedure here can be used multiple times, and that's great. Okay, so I've now captured that computation. I can refer to it by name because that name's available in that environment, and I ought to be able to use it. Great. So that procedure object is something that sits available to me, but again, has not been evaluated, that we don't have substitutions for x and y there. They're as variable names. And the last piece is that this little thing here we call an environment pointer. And it, from the procedure object, points back to the environment in which that procedure was defined. And we're going to see why we want that. But it basically tells us the context relative to which I want to evaluate my procedure objects. So this arrow points to the binding. This arrow is an environment pointer that comes back. Now, here's what happens when I actually call a function. If I want to evaluate some expression, followed within parentheses by some other number of expressions, which will be what a function call would look like, I first evaluate this expression, which is a name, and that says I'm going to just look it up in the environment, and I will get back the value, which is that procedure object. I then evaluate all of these other expressions to get the values of the parameters. And then I bind those parameter names in the procedure object to the values of the arguments that I passed in. And I do that in a new frame, which has as a parent the environment in which the procedure was defined. That's going to create a new context. It's going to look just like an environment. It's going to have names, in this case of parameters, with values associated with them. And relative to that environment, I'm going to evaluate the body of the function. And that's going to do just exactly the same rules. So I evaluate the body of the procedure relative to this new frame. And so, for example, if I were to now call max of 3 and 4, right there, I'm going to bind the value of that to z when I'm done. What do? I first get the value of max. It's right there, and it is pointing to that object. I get the values of 3 and 4. Those are easy. They're just numbers. And then I bind the parameters of the procedure in a new frame. I'm calling this one E2 for environment 2. I bind them to the values that I just got. And then relative to E2, I'm going to evaluate this body. That's great. Because now what do I have? I have a way of saying if x is greater than y, and where do I get the x? It's right there. It's relative to this frame. So I only see that value of x, I only see that value of y. I don't get confused by things up here in the global frame because I've created a new environment right there. And relative to that environment, I evaluate the body of the procedure. And now you can see this encapsulation is going to protect the interior details so that it doesn't matter, in fact, what names I use for the parameters here or whether they have bindings elsewhere, because they're not going to get seen by Python. It's going to use the local context, and in this case, return the max of these, which is the value 4. Mechanistic, yes. A little bit boring, yes. But really valuable for understanding exactly how the computation keeps track of what values to use, what variable names to use, and how to use the steps to do the computation we just captured inside that procedure object.